Okay, so this is where we left out last time. We were about to get started with actually the fun stuff, which is how to do the things that we just talked about in the introduction. So we are going to consider different operations that we can do in metaprogramming. The first one we are going to consider is the essential one, is how to get a class object. So we are going to go real quick over all the different scenarios that allow us to obtain a class object. And then once we have the class object, we can do all sorts of things that we are going to detail in the remaining of this slide deck. So let's get started with this. So class with an uppercase C is actually the entry point for everything related to reflection. Okay. As a matter of fact, if you look in the java.lang.reflect package, you are going to see that most of the class there do not even feature a public constructor. So most of the stuff that is provided to you by the reflect package is not meant to be instantiated independently. You are meant to receive instances of those other classes through an object of class uppercase C. Okay. There is one exception here that is mentioned. Going to get the pointer real quick, but that's not really relevant. So what we are going to do in this course, we are going to systematically go through an object of class to get handles on other reflection related objects. Okay, so this is really our entry point. Now, how to get that object of class to start off with is the object of the following slides. So there are different ways you can obtain it, okay, depending on what you have handy right now. So if you have, for example, an object of a certain class, like a class employee object, then from that object you can obtain the object of class. That's going to allow you to do some reflection, okay? If you have the name of a class as a string, then you can convert pretty much a class name as a string into an object of class representing that specific class, okay? And this is actually what we are going to use in the practice project. Because in those configuration files, I told you, well, ideally, I would like eventually to be able to put, 1 max as the name of the problem. And during runtime, your code is going to read the property file, take the string 1 max, and find a class named 1max and actually create an instance of that class, okay? So that's exactly what we're going to use in the practice project. And then sometime you do not have an object, you do not have the name of the class, but you have actually the class itself. So technically speaking, you have the name of the class, but you don't have it as a string, okay? So for example, you are writing code for that hierarchy that we used before with the class employee. So you can type the name employee as a class name, in your code. Well, if you have that in your code, how do you obtain an object of class that allows you to do some reflection at runtime? Okay, so that's what we are going to cover. We're going to cover all of those different cases and look at the tools that are available to us and obviously the syntax. So let's start with the first one. We want to retrieve an object of class uppercase C from an object. So here's an example. Example number 1, a string literal is an object. So if you have a string literal like foo here between double quotes, you can do .getClass, and that's the syntax to get actually the class object, okay? You use a method called getClass, and it's going to return you the class object corresponding to the class string. Okay, easy enough. Here, it's a little bit more disguised, but it's really the same thing, okay? It's the same thing because we have actually, when we call system.console, okay, we are going to get a unique console object. That's pretty much your terminal, okay? This is a terminal where your application is executing and where all of your, for example, system.out.println are going to go, okay? So right now we are asking to get that object by calling the static method console from the class system. And once we have the object, we immediately chain getClass, just like we did here. From the object, we use getClass to get the class object corresponding to the class of that object. So by the end of this lecture, you're going to be very good, probably, at capitalizing words as I speak. because when I say we get the class object for the class of that object, okay, in your brain you have to know where you have uppercase class and lowercase class. Okay, if it's not clear, if I'm starting to make sentences that are confusing you, just raise your hand, show me something that I need to repeat or go slower. Okay, but that's the jargon. Okay, we use the same word for different things, just a matter of whether we're referring to the class or the common word class. So that's how we are going to get a class object from an object. A few more examples that are less straightforward. Enum. So I don't know, I mean, everybody should have at least used one time in their life an enum in Java. If not, you can look it up. It's really trivial, so it's not a big deal. But like in this case, the only thing that is a little bit confusing for some students is that when you define an enum E, and you say, well, I have two enumerates in that enum that are A and B, okay? A and B are actually instances of the enum E. So that means that when you write something like a.getClass, it's correct, okay? A is an instance of an enum. So enum, interface, is abstract class, classes, all of that is at the same level, right? So here we are looking at an instance. We can call getClass on any object. And we're going to get the class object for that class. Example number 4, and we're not going to play too much with arrays for a reason that you're going to see in a few slides actually. So syntax with arrays and meta programming can be really annoying at times. Okay, so we're going to go. I'm going to show you the syntax, but I'm going to go light on that and certainly not trap you with that as the exam. Hopefully in a few revisions of Java, the syntax will be a lot better. But here we have our first example involving an array. Well, you know, arrays are objects, so same thing. Once you have bytes here defined as an array of byte, okay, of byte elements, then you can call getClass on it, and this is not a problem at all. All right. So the only problem is the way that the syntax that is used actually to show that the class we have is an array. That's something that's not really fun. Okay, scenario number 2. So right now we have been extracting with getClass from objects. Okay, all right. So all sort of object. Scenario number 2 is a different syntax, the .class syntax. .class syntax is used when you have types. Okay, so when you have object, you can do getClass. When you have types, you can do .class, and it's not a method. Obviously, it's an attribute. Okay, so types mean two things: primitive data types or reference types. So we're going to take a look here. In this example, if I do this, if I do Boolean B, so Boolean is a primitive data type in Java. Okay, so then I try to do b.getClass. It's not going to work, of course. It's not a reference, okay? So I'm trying here to use getClass, which is a method which is supposed to be applied on an object, on something that is not an object. It's a primitive data type. So we have this alternative here, class C equal boolean.class, okay? That is the alternative syntax to get a class object on something that is actually a primitive data type. So you know that in Java, all primitive data type have a wrapper class. Okay, so for example, int, lowercase I, int, has a wrapper class which is integer with an uppercase I, like any class name. Okay, so what happens here is that what you are really doing is you are trying to get the object of class that correspond to Boolean with an uppercase B. Okay, because there is no such thing as doing metaprogramming and manipulating like the class of a primitive data type. So you need to go to the wrapper class instead. Okay. So modulo this little conversion, okay, that is not too different from what happens with autoboxing and stuff like that. Modulo that little conversion, here you are here using a syntax that allows you to start metaprogramming even with primitive data types. And then you have two other examples on this slide that are a little bit less straightforward. In this case, printstream is a class name. So it's easy to think that, you know, because we have java.io.printstream, we have maybe like a method here, an attribute of a class, etc. No, this is package notation, okay? So java.io.printstream, you can also notice the uppercase for P. This is definitely a class name. So we can use the .class notation on primitive data types, okay, like we did up here. But we can use it, of course, also on reference data types. Okay, so any class name, you can append .class to it, and you're going to have access to the class object representing that class. Okay, so it's okay with things like print stream that are obviously classes. This, the last example, is okay as well. Okay, don't get confused. Int, yes, int is a primitive data type, but once you do a triple array of int, even if you do just a single array, dimensional array of int, that's an object, right? So you're talking about a class here. Like the class is array of int, right? So here, the class that we're talking about is array of int. That's a class. That's all that matters. Okay. So .getClass, the one from the previous slide, was for objects. Anytime you have an object, you can use that one. This one, you can use it every time you have a type, whether it's a primitive data type, a class data type, okay, or even a class data type that is pretty much disguised here with the notation, okay? .class will work in all of those cases. Third scenario. So third scenario is the one that interests us the most for the practice project, okay? Third scenario is I want to retrieve a class object corresponding to a class for which I just have the name as a string. Okay, and that's it. So I read the name in the configuration file, it's been typed by the user, no matter how you got that name, it's a string, and now you need to convert from string to a class object. All right, so the syntax is relatively easy. We have a method for name, and this method for name is a static method of the class, uppercase C. So we just go ahead and use, the notation we use for invoking static method, name of the class dot name of the static method, and we pass the string. Okay, the string that represents the name of the class. And we pass what is called the fully qualified name of the class. So, and this goes back to, this is as much as we are going to deal with packages in this course, okay? Like I told you at the beginning, we're not going to do anything elaborate with packages, but here you have to know a little bit about package. If you are writing a class called my local service provider, okay, in a folder named Duke, which is also in a folder named com, well, you should declare at the beginning of that class that it belongs to the package com.duke. Okay, so there is a relation between how your classes are laid out on the file system, so the folder and subfolder, and the notion of package and subpackage. Okay, so if you place that Java file, the Java file containing the definition of my local service provider class, if you place it in the right folder and you put the statement package with the corresponding name at the beginning of the file, then you're good to go. Okay, that's a fully qualified name of the class. That means this is the best name for a class. This is a name that suffers no ambiguity. There's no way to confuse, my local service provider with the other class named my local service provider that was written in a project, in package org.open source project that does this and that. Okay, so that's why you need this fully qualification. Okay, example 2. Yeah, sure.
What if I read found.duke.myLocalServiceProvider, then after that I write getClass and parentheses and colon. So what was that return?
So to make sure I understand what you suggest, you would have this string that is in green in the slide, and then after that you do .class.
GetClass.
.getClass? Well, then you're getting string. Do you see why?
So this is also string now.
No, that's not string now. So how many of you understand why in that example we would get the class object for string?
This is a package.
No, it's not a package. Okay, what is in green? That's a good question apparently. So what is in green here? It's a string literal, right? From the Java compiler perspective, everything in green on this slide is a string literal, okay? So it's an object, it's an instance of the class string. If you do .getClass, you do the same thing that we did, 2 slides ago, right? You have a string in your code, you say, give me the class for that object, and Java says, well, that's a string, so the class for a string is string, okay? It doesn't even look inside the string. That's the key. Now, And that's a good point. The difference here, why the string here has a different meaning in this slide, in this example, is because the string, we do not call any method on the string itself. We pass our instance of string to a method, right? So this method expects to receive a string, and then it reads the string. So the method for name actually is going to read the character in your string and figure out if we have a class like that right now in the JVM. And if we do have a class like that in the JVM, it's going to get the class object for that class and return it to you. Okay? So that's why we have strings in both cases. That's a good remark, okay? Except that in the previous slide, we call a method on the string object to get the class. And the answer is, well, you called me on a string, so yeah, here we go. I give you the class object for string. Here, we pass a string that is interpreted by a method. And the method returns the class object for the name. That's why this is useful. Otherwise, scenario number 3 would not be useful, right? If we are blind and we look at an object of class string and we say, well, all object of class strings are string, so here's a class object for string, that would not add anything compared to scenario 1 and 2. All right. The idea here is really, I want you meaning the Java, runtime, I want you to find a class based on a name that I wrote down. That's exactly the deal here. Does that make sense? Okay. Everybody okay with this? Cool. All right. So example number 2. Example number 2 is what I already mentioned like a few slides ago, is that ugly syntax, okay? So we have a syntax that allows us to express as a string, okay, as a text pretty much, data types like, for example, array of something. And this syntax involves names like this one, okay? Opening square bracket, then uppercase D. So this one is a class object for an array of primitive type double. That's it. So yes, there's a D, so you can guess double. The fact that it's uppercase means that, yeah, we're referring to the wrapper type rather than the primitive data type. It's still a little confusing, okay? It's even more confusing when you go to arrays of actually objects, like this one, okay? So here, we are trying to say, I want you to give me the class object that corresponds to an array of L, and L means reference. I mean, that's easy to remember, right? L reference. Reference to java.lang string. So this is a way, the same way that the fully qualified name here was a way to give to the method without any ambiguity the name of the class you are talking about. This is a syntax to tell without any ambiguity the name of a class that represents an array. So this is a single dimension array of double. This is a double dimension array of java.lang.string. A double array of string. And that's the syntax. Okay? So for those of you who are curious, I found you a quick reference. It's not in-depth, but the only thing that's in-depth is a Java language definition, pretty much specification by definition. But this is a good introduction to that syntax if you want to hear a little bit more about it. My guess would be that you are going to go to that kind of link only if you have to work on a program and the other programmers have used that syntax. Okay, or you have an absolute need to represent, a class like that at runtime, which we won't do in this course. Fourth and last scenario. So this one is a little bit redundant, okay? We talked about the dot class syntax, and we said it's okay for primitive data types, all right? But it's okay also for reference data type, even when they are disguised as, array-like definition. Okay, well, that's actually the preferred way to obtain a class object for a primitive data type. But there is another way, that's scenario number 4. So the type syntax, I'm going to go in detail here. The type syntax refers to those wrapper classes. Okay, you know that each primitive data type in Java has a corresponding wrapper class. Okay, int, integer. I keep using that one as an example. Well, those wrapper classes contain a field. That field is named type. And if you just access that field, you get an object of class that represent that data type. Okay, so it's just an alternative to using the .class notation. But you have to understand that it's only available with those wrapper classes. So for example, if I have here class C equal double dot type, okay, so double uppercase D is a wrapper class corresponding to the primitive data type double with a lowercase d as the beginning. So this is exactly the same thing than doing lowercase double dot class. That's it. So it's just an alternative syntax. Honestly, I don't know if it's a matter of legacy code or where that's coming from exactly, but we have this alternative here available. So you need to be aware of it just in the odd case, that you stumble into it in some code. But when you have to actually, when I ask you to extract, the class object for something that is a double uppercase D, you have a choice. You can use, one notation or the other. Okay. And same thing for void. Void is also a primitive data type. So you have a corresponding wrapper class named void with an uppercase V. And doing void.type is exactly the same thing than void lowercase dot class. All right. So we saw 4 different ways, actually 4 different scenarios to get a class object, depending on what you have handy right now in front of you, okay? Whether it's a type name, a string that represents the type name, an object, and so on and so forth. Now, there are many other ways to get class objects. It's by calling actually methods from the Java Reflection API, okay? There are a bunch of methods in the Java Reflection API that are going to return for you class object. For example, we're going to look at a few of them. Get superclass. So if you have a class object that represents, for example, the class secretary, to keep using that hierarchy that we have been using all along, okay? If you invoke on that class object, so you already have a class object, okay? You invoke on that class object the method getSuperClass. It's going to return to you another class object. And that other class object corresponds to the superclass of secretary. In our example, that would be employee, okay? So once you have a class object, you can navigate the inheritance hierarchy like that with method like getSuperClass, okay? Yes?
Suppose I have a class A, B, C, and C is inheriting from B and B is inheriting from A.
Mm-hmm.
So if I call this method get superclass in C,
Mm-hmm.
it will return me B or A.
B.
Okay.
Okay, so the question is, what if I have two levels of inheritance? A, B, C, 3 classes, C inherit from B, B inherit from A. So if I call getSuperClass, the class object representing C, what do I get? The class object for B or A? And the answer is you get the class object for B. Okay, you get the immediate superclass. Okay.
So what if I want the root of the hierarchy?
If you want to go up A, well, that's easy, right? You have your class object for C, you call getSuperClass. You get a class object for B, you call getSuperClass again on it.
But that is a scenario in which I know the hierarchy. Suppose I have a scenario in which I don't know the hierarchy of how the classes are there.
Then, if you do not know, so the question now is, what if I don't know at all the inheritance hierarchy? Okay, I have a class object for class C. I don't know if I have 1 superclass or 2 superclasses or n. Okay, what do I do? Well, in that case, you recursively keep calling getSuperClass until getSuperClass returns null. So that would be, you would have to explore, But the funny thing with that example, actually, is that it shows you that during runtime, you can execute a loop. So you don't even know how many times you're going to do getClass, but you keep executing an iteration, a loop, a recursion, whatever, that's going to query what is a superclass, what is the next superclass, what is the next superclass, until you meet actually object. Okay, so before you get even to null, I guess you could detect, once I get object, uppercase O, then yeah, I know that I'm pretty much done. Okay, so either way, wait for the null or wait for getting a class for the class object. Good point. So it's interesting because that example really shows that you dynamically play with the structure of your program. You don't even have to know anything. You discover it, during runtime, which is kind of cool. All right. Another example here. I don't think this example adds much compared to what we just discussed, but for example, in the JavaX library framework, we can go JavaX swing jbutton.class. So we obtain the class object for the class jbutton in that package, okay? And then immediately we chain a call to get superclass, okay? So in your example, that would be class C, you know, we get the class object for class C, and then we immediately do a get superclass. And if we want the superclass above that, we could chain another call to get superclass again, no problem, okay? So that's what we do in that one line. We obtain actually two class objects in a row, okay, in a chain. All right, other example, second example of methods that return actually class object and that we are going to probably use, get classes. So that one returns the member classes of a class object of a class, okay? So just make sure that you do not confuse, that's a very easy confusion to make. Make sure you do not confuse member classes and class members, all right? Example of class members, a field is a class member, a method is a class member, okay? Member classes are classes that are defined inside another class. For example, inner classes or nested classes, okay? In Java, you can define a class inside another class when that inner class is only used, you know, in that class, or it belongs in that scope, you know, for the purpose of organizing your code. Okay, so that's kind of a way to use encapsulation, okay? To use abstraction to hide away some classes sometime. You can use it for different things, but that's one of the main use. So if you do that kind of thing, you might at some point want to be able to get information about, okay, I have this class here, this class object that represent a class like secretary. I want to know if I have any inner class or nested class inside secretary. That's what you would use. You would use this method here, get classes plural, okay? So it's going to return you an array of object of type class. You are going to notice, I mean, either because you are good at playing Where's Waldo or because there is like a collab that is pointing right next to it, okay? But you're going to notice a weird syntax here. If you've never seen it before, don't worry. It's just generic syntax. We're going to talk about this extensively in the next module, okay? Our next module will be on generics. We're going to explore all of the detail of that syntax, or most of them at least. But for now, just go with it. Okay, just go with it with the example and just use it as a recipe when you use it in your code, and we'll clarify that very soon. So in this case, we say that we want an array of objects of class, okay? And to get this array of objects of class, we go to the class character. We get the object of class that represents the class character, and then we call get classes on it. So we always start with a class object, okay? That's the theme with all those methods we're exploring right now. And this is going to give us, and this is important because we have another variant coming right after, this is going to give us actually all the public classes that are inside the character, that are declared inside the character classes, okay? So that's going to be inner classes, nested classes, including everything that has been inherited. So these are the rules for that method. When you use get classes, you only get public, okay? Only public inner and nested class, but you get also everything that has been inherited. So everything that is public, in other terms, everything that is usable on an object of class, in this example, character, okay? Every inner class, nested class that is accessible, you get it. And this is in contrast to the next method. The next method, which is called something very similar, getDeclaredClasses. So what do we mean by declared classes? Well, that means that we are interested in getting, actually given a certain class, all of the classes, interfaces, enums, etc., that are explicitly declared in it. So we are not going to pull down everything that is inherited, but we are going to get everything that is public and everything that is also private. Okay, so the difference between the two, it depends on your goal. Okay, if your goal is to explore and see, for example, I have a class secretary, I want to see any inner nested class that I can access there with an object of class secretary, then that's the first one. Okay, everything that's public, whether it's inside the class or inherited. And then this one is more, okay, I want to look at only what is defined inside this class. So I don't want to look at what is inherited, but I want to have access to everything that is declared in that class, whether it's public or not. Okay, so depend on what you have to do. So typically, as an exam, there's always one quiz question or something like that that goes on and say, okay, I want to obtain this, and choose the appropriate method. So just make sure that you pay attention to the little differences that we highlight here during the lecture. Okay. And now there are going to be other variants that are going to come from this. So we talked about getDeclared classes, the classes that are declared inside another class. So that assumes that I have already an object of class, that represent that class, and now I want to know everything that's, I want to get object of class for everything that has been declared inside of it. Well, now I want to do the opposite. So getDeclaringClass assumes that you have already a class object, okay? And that class object represents one of those inner class or nested class, that is declared somewhere inside another class. But for some reason, you don't know the name of the class it has been declared in. So now, by calling getDeclaringClass, you can actually obtain a class object that represents that class where it was declared, okay? So let's say you have an inner class inside of secretary. I don't know, let's make up a class, paperwork, okay? So inside the class secretary, I declared a class paperwork. It's public. So somehow I got an object, a class object, that represents the class paperwork. I call getDeclaringClass on it. Now I get a class object that represents secretary, aka the class where paperwork was declared. All right. So you have different variants of that method. I should say actually different implementation of that method. One that is meant to act on an object of class field, one that is meant to act on an object of class method, one that is meant to act on an object of class constructor. Field, method, constructor, these represent things that you can find in a class, okay, beside another class. Okay, so here you get a glimpse of what we're going to cover next in the second half of this lecture, which is beside obtaining a class object, then what are the other classes in the reflection API that allow us to manipulate things like methods, like to get an object that represents a method and call that method. Well, there is a class for that method. To manipulate field, there is a class field. To manipulate a constructor, it's separate from method, okay? Constructor are special animals. So we have also a class in the reflection API that represents, model a constructor. Yes, you had a question.
Yeah, why can't I, instead of using getDeclaringClass, why cannot I use getSuperClass? Because
okay.
Is a child of secretary.
No. So the question is, it's a good point. Why can't I use getSuperClass instead of using getDeclaringClass, okay? If I have a class secretary and I have paperwork inside of it, then paperwork is a subclass of secretary, right? And the answer to that is no. There is a difference between the relation of subclass, okay, and the relation of inner class, nested class, okay? So if you say, for example, you have employee, a subclass of employee, secretary, a subclass of secretary is legal secretary. Yes, you would use getSuperClass to navigate that. But what I said is inside the class, inside the code of the class secretary, I define a new class. Okay? So I use the keyword class, public class, blah, 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 paperwork, but I write the code for that class paperwork nested inside the code of the class secretary. So that doesn't make paperwork inherit from secretary. It's a totally different thing, okay? I never said paperwork extends secretary. All I did is write the code for a class inside of another class, and now I have a nested class. Okay, so two different scenarios. That's why we need two different tools, okay? getSuperClass navigates the inheritance hierarchy, the extend relationship. getDeclaringClass allow you to get pretty much the context in which a class was declared. Okay? All right. Another example here. Well, we are using that field class in that example. So we have f, which is a variable meant to hold a reference to an object of class field, and we call system.class. So we obtain the class object for system, and then get field out. So remember when you do system.out.println, stuff like that. So that's what we are doing here. We are looking at this out field, and we are trying to actually get that field. And once we have the field, we call on that field getDeclaringClass. So what we want to obtain here is the information that that field was declared inside of the class system. So we are going to obtain an object of class that represent the class system. Everybody okay with this? All right. So in the second half of this lecture, that's what we are going to do. We are going to play with fields, method, and constructor. Okay, but right now we are just using that to illustrate what you can do with those class objects, and we are learning to obtain the class object in every possible manner, pretty much. So if you liked nested classes, you're going to like this probably. So you have to let me know if these concepts are new. Okay, if you never played with nested class, inner class, anonymous classes, things like that, just let me know, okay? Come and talk to me after the course, or come to office hour, whatever. Talk to the TA during online session, whatever helps, okay? But I'm going to assume that I can actually give you the gist of what an anonymous class is just with this example, okay? So if you've never seen it before, I'll go slow, okay? So here what we are talking about is anonymous classes. So there's a bit of a special weird animal. So what is an anonymous class to start off with? Well, look at the syntax here. We have a public class, my class. Okay, so standard stuff right there. We have a static object O. So O is a field, a static field in that class. But that's really not really relevant for this example. It could be anything. And we create a new instance of the class object. So no trap here. This is a field meant to reference an object. We create an object. But right after the call to the constructor, normally we put a semicolon here. And if we put a semicolon after the parentheses after object, that means I call the constructor of the class object, give me an instance of the class object, I put the reference in O. But here, we are doing something more. And this is maybe what some of you have never seen before, okay? We open curly braces like if we were writing code, and we are writing code. And between the curly braces, we actually put some code. We put actually here the definition of a method. It looks a little wonky in this example because the method is public void m. It takes no parameters and it does nothing. The code is empty. But I could write code there, okay? It's just doing nothing to keep the example small, I guess, okay? But it could be like a full-fledged definition of a method that returns a data type, that takes 5 parameters, that has like 20 lines of code in it. And as a matter of fact, not only I could have the definition of one method here, but I could have the definition of as many methods as I want. And I could even have the definition of attributes. So what is the unit of code in Java that allows you to define attributes and methods and pack them all together in curly braces? A class. That's perfect timing. Thank you for that special effect. So we're going to try to cue those in time. This is awesome. So we are writing a class here. That's what we are doing. We are writing a class on the fly. That class has no name. Hint, that's why they are called anonymous classes, okay? So we write this part in yellow here is the code for a class that has no name. The only thing I can tell from this syntax is that class without name inherits from the class object. And there is no keyword extend because that would be too easy, right? That would be too readable. So we don't have a keyword extend. We don't have any sign that there is inheritance, except once you understand the syntax for anonymous class, you realize that you write an anonymous class after the name of a constructor object, okay, after calling the constructor. So it's a way of saying I call the constructor object of the class object, but I really don't want an object. I want a subclass of object, and let me give you the code for that subclass of object right now, right here. So that's how it works. If you look at it like that, then it starts making sense. But you could say, I fully expect an extend keyword here or something to remind me it's inheritance. No, it's not there, but it's there. Okay, it's doing inheritance, but it's not using the same traditional syntax we do. So this in yellow is an anonymous class. We have no way really to refer to its name. All we know is that it's a subclass of object. So if you have an anonymous class that is a subclass of secretary, then instead here you would call the secretary constructor, right? So by default, if you have an anonymous class, but it's not a subclass of anything you wrote, then by definition it's a subclass of object. That's kind of like the end all case, okay? Every class in the Java virtual machine is a subclass of object, directly or indirectly, okay? So that's why we are using object here. And then we have another field here, static class C equal o.getClass, getDeclaringClass. So what are we doing here? Well, we are taking this object O, okay? This object O, its class is, I don't know the name. It's an anonymous class. And I try to get the context of that anonymous class. What class were you declared in? And here's the trick. An anonymous class is not considered to be declared anywhere. It's not a nested class, it's not an inner class. Now, besides the technicality of it, you and I can look at this and say, well, yes, it's been declared somewhere, obviously, and it was declared into my class. So it's just a matter of what do you mean by declared common sense, okay, among programmer, human programmer, and what do you mean by declared when you talk about that getDeclaringClass API in Java. Okay, so that's a little trap you need to be aware of. So if you call getDeclaringClass here, you're going to get a no, which means I cannot find, actually, it doesn't mean it's not declared anywhere, it means I cannot find the declaring class. Slight difference. So that brings a new concept, because that's not acceptable, right? This would mean that we can never figure out what class an anonymous class belongs to, where it has been actually declared. Yes, you have a question?
So you said it will return a null. Why wouldn't it have a runtime error?
Okay, that's an interesting question. The question is, why does it return a null instead of raising an exception, like runtime error? I guess it's not really, I guess it's the people who defined that framework didn't consider it was really an exception. It's just a way to tell you, well, this is an anonymous class. If anything, if you add a class object, on something, and you call getDeclaringClass on it, and you get null, that's your cue that this is an anonymous class. Whether or not that information is useful, I don't know. I never had to figure out if a class object I had in my hand belonged to an anonymous class or not. That's never a decision I had to make. But if I had to make that decision, I guess there's a tool to do that. So it's not an exception as much as it is information. Sorry, go ahead.
Is there a true purpose to using an anonymous class then?
Yes.
Okay.
The true purpose of using anonymous class is to make you want to do functional programming. It's half a joke, but it's not really. Anonymous class were brought into Java as a way to allow you to do things on the fly. Like you call a method, you want to pass a class to that method, but you want to build it, on the fly. You don't need actually to bloat, your hierarchy. Let's say you have already 50,000 classes in your project. You don't have to add, double that number of class, because you have a bunch of scenarios where you need to have a small class to pass to a method, right? So anonymous class are really cool to do that. The only thing is the syntax is a little bit, like many things in Java, Java is known actually to have a syntax that is really verbose. So this syntax here, if you have to pass like a class that has just a method, that's a lot of junk, pretty much syntactical junk, to just say I want a method that takes nothing and return nothing. Okay, if you had a method that takes an int and return, for example, 2 times that int, same thing. You would probably get a little pissed after a while, having to write all of this just to do something very simple. So at that point, what we are going to go with in the future are functional interfaces, okay? We're going to look at way to say, well, when really all I care about is passing a method, really what I want to pass is a function, Okay, and Java 8 provides us with a syntax that is a lot better, a lot easier, a lot lighter to do that kind of things. But other than that, anonymous class allow you to do the same kind of work, right? But just that was an intermediate, I would say, notation syntax. Okay, all right, so where are we right now? So we have this null here that tells us, this is an anonymous class, but what if I want to know, because I'm stubborn, I want to be able to get a class object that represents my class when what I have is O, because I know that O is an anonymous class now, and I know it had to be declared somewhere. So I want to know about that somewhere, the class in which it was declared. Well, the correct terminology is enclosing class. So it's not called declaring class, okay, because get declaring class will tell you null, but it's called get enclosing class. So in that example, if I call on O, get enclosing class, you are going to find that you get an object of class that corresponds to my class. Okay. Like I told you at the beginning, most of those slides are derivated directly from the Oracle tutorial, so I gave you the link at the beginning of the lecture. Watch out, if you look at this, there is actually a typo. I don't know if it has been fixed yet, but as of last iteration of this course, there was a typo where the example was using getDeclaringClass in both cases or getEnclosingClass in both cases. Okay, so this slide and the previous slide, if you look them up in the Java tutorial, you might see a difference in the code, but it's actually a small mistake. Okay, so be careful about that. Yeah, question?
So in this case, I just have a question. So if I want to use this function m outside of the scope of my class, so how will I exactly get access to that? So do I use my class.o.m directly?
Yeah. Yeah, that's exactly it. So the question is, okay, we saw the syntax, on how to define an anonymous class, blah, blah, blah. But what if I want to use that method m that is inside, the anonymous class, and I want to use it based on, I don't know, I have an object of class my class. So let's say you have an object of class my class called p, okay? So you can do p.o to access actually the object field inside, and then from there you can access the method in there. So it's a way to, again, it's an extension of encapsulation and abstraction. It's a way to say, well, there are some cases where I need a class in my project, but that class is really tightly linked to another class. Okay. So for example, you are going to see a lot of people define enum instances inside of a class, because that way they can do something like, employee dot and then a constant that represents something that is really making sense only in the context of an employee. Okay, so if you have things like that, like for example, you have a class student and you have a status of the student, which is a field, and this field is an enumerate, and the enumerate is sophomore, freshman, senior, junior, stuff like that. Those enumerates really make sense only in the context of student. So when you use them, you would do student.status.sophomore, for example. And that makes sense because that reminds you that yes, it's an enumerate, it represents the status and the status of a student. So that's really, a matter of grouping together things that belong together logically. Yep.
And will I get the object O in getClasses method or the getDeclaredClasses method? In case I want to go, I just want to do a check whether I have an anonymous class inside my class.
Oh, if you want to obtain the anonymous class, okay, this is a good question, but that one I cannot answer right now. I have to look it up actually, because that's a kind of a wonky scenario I'm not familiar with. But this is a very good question. The question is, what if I have a class object corresponding to my class, and I want to list actually the anonymous classes in it? My first instinct would be to go with getDeclaredClasses. Okay, because that's the method which purpose is to get you everything in that class. Ignore the inheritance hierarchy, but give me everything whether it's public or private. However, because this is an anonymous class, I'm not quite sure what the answer would look like. So I would have to double check that.
Will I get declared class and then check if declaring class is null to find out that it's anonymous? and then probably action.
Yeah, I might just get a class. The remark, again, for the recording, the remark is, well, so does that mean that I get a class object and I need to check, you know, with using getDeclaringClass? If the getDeclaringClass gives me null, then it's an anonymous class. That should work. I don't see why it would not work, but I'm not going to guarantee you it works until I try it, okay? Because I'm that paranoid. But the idea is, yeah, you're going to get an array, you know, with getDeclaredClasses, you get an array of class objects. So now one of those class objects happens to correspond to an anonymous class, which is my assumption right now, is that you would get a class object for the anonymous class too. And then if you really want to sort out whether it's anonymous or not, then you can use that trick we were talking about in the previous slide. Yeah. Well, thank you. These are very great ideas for the exam. Man, I was kind of like racking my head. No, I'm kidding. I don't do that. But okay.